I promised you to see what slides look like before Beamer existed. These are they. They're really quite fetching. Okay. Yeah, so basically then what I would call the new frontier in auctions is not single unit or single object auctions, but rather multi-unit ones where there's multi-unit supply and multi-unit demand. Some of these auctions are no different from static auctions. And how does that happen? Well, when you have something like a simultaneous dependent auction, one example of that is every morning and every afternoon in Canada, there's something called a receiver general auction, and the 25 banks participate to borrow money from the federal government. And what happens is there are millions of dollars at place. They have to buy it in blocks of $1 million, and they pay for each block what they bid for it. And then they aggregate all the demand curves. And when they find the supply curve, they cut it off, and then you pay what there's an allocation, and everybody pays what they bid for every one of the $1 million. Another kind of case is where you would do the same thing, but you would charge one price for that, namely the price for the highest person who lost. And so those aren't going to be very interesting dynamically, right? Because they just occur, they just happen. The ones that are going to be interesting are what Weber called sequential auctions, and you buy one unit or a block of units over time. And so like the Sydney fish market is like that. They bring in a bunch of pallets and they sell them more or less one by one. What do the theorists have to say about this? Well, most of the theory is all done in the single unit case. So Weber has a famous paper buried in a book that basically says if you have single unit demand and multi-unit supply, then the price is going to follow a martingale. And typically that martingale has the mean of the kth order statistic of, if there's K units for sale, it's the kth order statistic of valuation, or the K plus first. So you're going to choose a reservation price to just clear the market. If you want to get any shape, then Lafonoiselle and Robert put some affiliation in, and then they got a U-shaped curve. If you do it in the common value paradigm, then McAfee and Vincent get a declining price curve. And so what did we do in this paper with Donald and Robert is we had these private values, multi-unit demand that was Poisson, and we were able to get a supra-martingale. So the price goes up on average. And we wanted to look at some data from Siberia, a town on the Yenisei River called Krasnoyarsk. Krasnoyarsk is where they sent Lenin when he was a bad boy. And they have lots of nuclear devices in Krasnoyarsk. You can't find it on any Russian map, but Rand McNally has many maps with it because it's so important to the CIA. So you know, what I want to do in the next little while is just show how we put structure on this. So at any period there, in any week, so what are they selling, and why would they be private value? Well, they're selling timber export permits. So if you want to ship timber out of Krasnoyarsk, the region, you need to have a permit. And the permit allows you to ship out a boxcar of lumber, say to Italy or something. And so if you don't have this export permit, you can't ship it out. Now, of course, this is Russia, which means that you can also always do something, but you know, let's pretend that the law prevails. And and one of the things about these is that they can't be traded and they expire if you don't use them. So there's not like you could have a secondary, in some things, you can buy them on speculation and then sell them aftermarket. These one prohibit that. And so there's this fixed supply and you need them. And so what we imagined was that, and how do these auctions work? Well, one thing is they have a reserve price, and then the price, I actually went to this auction, it's more or less how it's described in words. People hold up a white card, and as the price rises, they drop the card. Now, from time to time, they would put the card in their pocket and light a cigarette and then put it up again. So, you know, it wasn't strictly true, but it was pretty good. And then and we weren't actually looking at the intermediate bids. We were just looking at the market clearing bid. So the fact that they may have exited wasn't really too bad. And so what we want to do is consider a seller who has T lots of these export permits. And what we're going to do is we're going to imagine it's this Japanese auction. There's N people, potential bidders. Why was fixing N important? Well, what happens is from auction to auction, there's different amounts of participation. And the maximum was around 20 and the minimum was around 3. And so we needed to have a model that, you know, could account for that. And the simplest model is that binomial model I showed you. You fix N, and then you fix the reserve price, and then you get a number of people showing up, and then each person shows up, has so many bids according to a Poisson model, and now you have a model of demand. And they're risk neutral. So what happens is you get a draw from this Poisson, an M, and that populates a vector. For the ith bidder, it's W1, W2 to WMI, and then there's a bunch of zeros. And these are those little step functions that I described early in the talk, except now everybody has one, and they're going to aggregate. And as I said, what you want to have happen, so that aggregate step function aggregated all the bidders, we'd like that to be more or less stationary in a probabilistic sense as we drop people from it. And it turns out that the Poisson model keeps that going to the right with the same average behavior. It can't change the realizations because they are what they are, but in a probabilistic sense, it does. And that just makes it simpler. So the demand goes over, supply goes over. And then we imagine that these are Weibull. Here's the number of people who show up. How do they show up? Well, anyone who has a positive number M comes, everyone who has a 0 doesn't. So the probability of a positive outcome is 1 minus e to the minus lambda. And that's the Poisson, or the binomial model of that. So we're going to have a model of participation and a model of the winning bids. And as is typical, F of W will be a Weibull. And then I'm going to kind of just skip through all of this. You can read it at your leisure. But really the important thing about all of this is theorem 2 that says that this grinds out an efficient allocation. And the reason that's important is that if we have another mechanism that also finds an efficient allocation, we're going to use that simpler allocation, which in this case is a generalized Vickrey auction, to simulate. And so we get data like this. You know, there'll be 4 lots. They'll have different units, different reserves, different winning prices, As I said, here's the key insight that we're going to use to estimate an objective like this. Or you could, in the actual paper, we did generalized method of moments, but the key to any estimation strategy is to be able to simulate these winning bids at the auction. So you essentially generate a Poisson from here. That'll give you how many times you generate a Poisson for every person in the set 1 to n. All of the ones that are positive allow you to give you an estimate of the expectation of nj. So you simulate how many units everybody wants. You count up the number of zeros, and that gives you the non-participants, and then the 1 minus that is the participants. Then for every m, you generate some values for a current value of theta, and you run a Vickrey auction, and you find the winning bid, and you save it, and you do that s times. Once you have, that's kind of unfortunate that the objective function is s as well. Once you have that, you can form p bar. You can substitute p bar into that square there and into there, and then you take a step and you keep doing that, and you're done. And once you have the estimates, you can then compare other methods. Before I hand off to John, I will mention that there's another paper in the subdirectory of his slides that has something about a Hui. And the Hui is very similar as well, in the sense that I want to keep the auction symmetric, but in this case, it's finite in horizon. There's a finite number of units, but what makes it attractive is after the winner wins, he's dropped out. And if you condition on the highest order statistic, the remaining sample is still IEID, and so the game remains symmetric down the line, and you can look at dynamics that way. So I think I should probably hand over to John.